So today we are solving this problem, unique length 3 palindromic subsequence. So let's read the question first. So given a string s, return the number of unique palindrome of length 3. So basically one string is given to us and we have to return all those subsequences, not necessarily it should be a substring, but subsequences. And it is still only counted once if we have multiple similar subsequences. For example, you can see here, let's say this is our string, right? So we have to find all the 3 length subsequences, for example, which should be palindrome. For example, here we can say that ABA is a palindromic subsequence of length 3, then this guy would be a valid answer. Similarly, we can have similarly we can have this guy KLK, right? KLK is also a 3 length palindromic subsequence. Remember, it need not to be necessarily a substring, but it can be the substring as well. Okay. Similarly, we can have ACA, right? We can have an ACA is also a palindromic subsequence here. So basically 3 length of subsequence we have to find, that should be the palindrome as well. So here you guys can observe one thing, that any palindromic subsequence or substring would be the palindromic of 3 length if the first character and last character is the same, right? Then only it would be possible to become a 3 length palindromic, right? So you can check everywhere. Here also K and K, the last element are same. In between the element may be different or may be same as well. So our intention is that if we are finding the 3 lengths subsequence in this string, its first character and the last character should be same, and doesn't matter in between this character is same or not. Anyway, we will find a palindromic subsequence. So this is what we have to do. So there could be multiple, right? ABA is one, ACA is another one, and KLK is one, KMK is another one. So there could be multiple, right? KMK is another palindromic subsequence of this substring. So this is what we have to find. Now the thing is how to find it. Okay. So let's read the fully the question is. So anyway, palindrome is the one which we were discussing. So we have to basically find the total number of such palindromic subsequences, number of unique palindromic subsequences. So we have to find the only uniques. There could be like similar as well. For example, let's say we have a string like ABAA, right? So in this case we can have ABA, and this also will be form ABA. So only one would be count. We cannot go for the duplicates. Okay, so only unique 3 length palindromic subsequences we have to find. So let's think about the approach here. As you guys would be observing here, that we have one intuition here, that first character and the last character. Okay, if we found the first occurrence of any character, for example, we found first occurrence of A at here, right? And the last occurrence of A at here, right? That means whatever is in between, that many subsequences of length 3 would be palindromic, right? We can have like ABA, we can have ACA, right? So we found for A, starting at A and the last occurrence of A, there are 2 unique characters. So that means we can find the 2 palindromic subsequences. If there were another, like if duplicate was there, then we would be counting only to the unique one, because anyway, let's say there was one more C. Okay, so it would be A, B, C, C, A. Then only these 2 would be there, because C would not add any value because it would generate the duplicate. So what we will do is we will find for every character their first occurrence and the last occurrence. Like in A, it occurred first at 0, then it occurred at the index 3, right? So between 0 and 3 we have to find that how many unique characters are there. So here we can say there are only two unique characters. So if there are two unique characters, then we found only the two palindromic subsequence. Similarly for A we found, similarly for K also you can see. K, first occurrence at K, what, where it occurred? So K occurred at index 4 here, right? It occurred at index 4 and 5, 6, 7. It last occurrence is at 7. Now whenever we found the first occurrence and last occurrence of a character, then we have to find the number of unique characters in between them. So for example here L and M, only two unique characters, right? So two more palindromic subsequence would be there. You can see here KLK and KMK. So 2 plus 2. So there are total 4 palindromic subsequence we can find for this string. So now you guys would be understand that what would be our approach. Now the thing is how to write this thing in terms of code. So let me do that. So basically what we are doing is we are creating two integer array of size 26, right? 0 to 25, first and last. So why of size 26? Because it's given in the question that all the characters are small characters and there are only 26 characters. So initially you can observe here in integer first every value is -1. There is a reason why I have put initially -1. So what we will do is we will traverse through this string, right? So as soon as we find A, right? So A is occurring first time. So what is the corresponding value of A? So it would be like whatever char at A, let's say as let's say this is as at 0, right? So we can do it like this. Yeah. So suppose we are traversing it from left to right. So at I equal to 0, what we found? At I equal to 0 we found the character A, right? So for this character A, if we deduct, okay, so let's say s dot char at I, s dot char at I, if we do minus A, right, then we will get the numeric value of it. So this will give us 0, right? Because A minus A, it would be 0. So what we will do here is once we get the 0, we found this 0th index, right? So this is first time it is coming. So at I equal to 0, what we found? We found the this guy, the integral value 0. So at 0, what we can put here? We found the A. So we will put here A. So that would be 0. So this is our first occurrence because so far it was -1. So what we gonna do here? We will put here 0 because at 0 we found the A, correct? Now we are going to here B, okay? So B we found where? B found at B at 1, right? So we can put at 1, it would be 1, right? Similarly at C we found 2, correct? Because C minus A will give us 2, right? So we are just getting the numerical position of the alphabetical characters, right? Now we are here again coming to A. So at A, when we will again find 0, we will go for this first occurrence, right? But in first occurrence it is not the -1. You remember initially we put everything -1 and whoever is occurred we updated. That means 0 is already occurred, so we don't have to update now. So what is the currently its location is index is 4, right? It is 0, 1, 2, 3. Yeah. So A occurred again at 3, right? So here let me put it. So at index 3 in the last we have to put it, right? So at this is 0 value, right? 0 value is occurring at index 3. So what we will do here? We will put here 3. Okay, we have put it 3. Now we will go to next one. So it is K, right? So anyway, whoever is occurring at last we are every time updating. Like B it would be 1, for C it would be 2, and this A it is already again occurring, so it became 3. Now at K, so we are coming at K. So what is the index value of K in the this? So K minus A, what we are finding? at index 4. So k value would be k minus a, which is 11, right? So we will go for the index 11. So at 11 here, let's say this is our 11. So at 11 what we will mention? We will mention it 4, right? So at 11 we found the index 4. So it is coming first time. So we are putting it here 4. And here also we are putting at 11 we are putting it 4. We are mentioning that what if there is only one character? In that case even the first and last would be same, right? So every time we are also operating in the last also, but in first only when it is negative, right? Then we will go to L, which is occurring at index 5, right? So we will go here. L value is 12, right? So L minus a would be 12. So we will somewhere find it here. Okay, now we will put the value. So it is 5, right? Index 5 we found the L. So far it was -1, but now we are putting it here. So at L we are putting it 5, and in the last also we are putting it 5 because we don't know, there could be only single character as well. Now we are coming to this M, right? So M is occurring at 5 index, right? 6 index. So M is coming at index 6. So M value, what is M minus a? M minus a gives us 13, right? So it would be somewhere here. So we will put here 6, and here also we are putting 6 because first and last is every time we are updating. Now coming to K. So this guy is at index 7. So what is the value of K? K minus a is 11. So we will check here in this first. So at 11 we already have this value 4. That means it is already occurred. Now we are coming to here. So at 11 so far it was 4, but now we found a new value 7. So this should be the last value now. So we will remove this 4 from the last. Remember, from first we will not, because it's already a non-negative value, right? So here we will put now 7. So now we can see here that we have recorded all the first occurrence and the last occurrence for every character, correct? Now what we will do after doing this, we will traverse through these first and last, right? So we will go from here. So look at here. At first 0 is occurring, right? That means A. So A is occurring, and what is the corresponding last occurrence of it? Corresponding last occurrence is at index 3. So A is starting at index 0 and ending at 3. So how many unique characters between 0 and 3? So this is our 0 and this is our 3. Okay, this is index 0, this is index 0, and this is index 3. Now see how many unique characters? B and C, right? So once we found first and last occurrence, what we will do is we will traverse through this same string, right? Starting from 0 plus 1, because we are excluding these conditions 0 and these in between. Basically we have to exclude the 0 and 3. So at 1 and 2 we have to check. So how we will do is, because here in this example I have put BC, but there could be like duplicate as well. So for that reason we can create a hash set, right? Let's say we have a set. So what we will do is, starting from 0 plus 1, here we are starting at start index is 0, right? So starting at 0 plus 1 till this guy less than 3. So we will find that we will add B and C to our set, right? So there would be B and C in our set, which could be a duplicate as well. That is why we are using set. So what would be the size for it? It will give us the 2 size. That means we can we have found the 2 unique characters between the first and last occurrence of A. So we will keep on adding this for same all of them. Now come here. We are done for A. Now we are coming here for B. So B is starting at 1 and ending also 1. That means there is nothing, there is no possibility of anything which is starting at B and ending at B, because we are looking for the 3 size thing. So now we will proceed ahead. We are coming at this guy. So this also starting at 2, ending at 2. That means there is nothing in between. Now we are coming here A. So A part we have already done, right? 0, we started at 0 and ended at 3. So similarly we will check. So what we are doing is we are basically for 26 time starting from 0 to this, we will check for all of them, right? So then we would checking for all these values, but these are already -1. So those who are -1, we would be keep on ignoring them because they are not existing at all, right? Similarly then when we will reach at k, this guy is at k here, so we will again find a pair that it is starting at 4 and ending at 7. So let's look here, 4 and 7, right? We found a pair 4 and 7. Now in this pair we will check that who all are the unique there. So see here, L and M, right? So our set would be having L and M if we run a loop starting from this guy 4 plus 1 till last occurrence less than last occurrence, right? So it would be adding L and M here. So we will found again a size of 2, right? 2 unique characters would be there. So we will again make +2, right? 2 plus 2. Okay. Now we will again proceed ahead. We will come to this guy here, but this is 5 and ending also 5. So no unique correct, no possibility of any uh, occurrence of 3 sides or palindromic stuff. Then we are coming to this guy 6 and 6 is, it is also starting at 6 ending at 6. So finally we found total 4 palindromic substrings would be possible, right? So guys, here we are using the constant space only, and this set would also be go only up to the 26 size, right? So we are doing in O of n time complexity and the constant space complexity, right? I wouldn't call it O of 1, but yeah, we can, a better word would be constant space complexity, which is technically or mathematically is O of 1 only. So this is how we would solve it. Let me show you my corresponding code for this. So this is my code here. As you guys can see here, I have created the first and last of 26 size, and then in the first I am filling -1 initially. This is my answer variable. Now see, what we are doing is we are traversing through this string, and we are taking the numerical equivalent index of whatever character is there, and then we are checking here that if first x is -1, means if it is coming first time, then only we are putting here first x, means at whatever index we found, like we have only 26 size, right? So we are fulfilling those indexes, first occurrence I, right? And last occurrence we are all every time putting this I, because anyway when we will be coming to the very last one, this guy would be finally having the last occurrence index, right? After doing this first and last filling for every character, we will run a loop for 26 times, right? Starting from 0 till 26, because we have anyway only 26 sides first and last, right? So what we gonna do here is we will check here that if first I, means if it is -1, that means it is not occurred at all, that means we don't have to check for it. But if it is not the case, that means we will find the first occurrence and the last occurrence. So see here, I have created one hash set. This hash set would be checking for the how many characters are occurred between this, right? Similarly what we were doing here, like for this a, we started at 0 and ending at 3, so we are finding that value. So see here, you can observe here we are making first I +1, basically the start index +1, and we are stopping last I, right, where it has occurred. Before that only we are stopping, because we need to find in between, just like see here 0 and 3, so we are starting from 1 and ending at 2, right? So we will check only whatever is there in between. So for that reason, see here, I'm starting from first I +1 and ending at last I. Then see here what I'm doing, I'm adding all those characters into this hash set so that only unique values would be added. Now after doing this in this for loop, what we are doing, we are adding the size of hash set to the answer, because there would be multiple such cases, right? So finally we will have all the combination and we are returning this answer. So let me execute my code. Yeah, so let me submit it. Yeah, so thank you for watching this video. If you guys have any concern, please make a comment over there. Thank you.